about 10 minutes or so of your time today just to discuss a number of advancing pump technologies taking traction in food, beverage and dairy production. Lennox Pump and Process. We are Ireland's leading supply partner of hygienic positive displacement pumps and related ancillary equipment. We are a total solutions provider in the field of process pumping. We are not a pump distributor. We supply pump units, but we consult with the end user. We map out a solution for that end user, and the pump unit then comes as a secondary piece of equipment. We specialise in the hygienic transfer of delicate, shear-sensitive, abrasive, and difficult to handle product. And this would be typically the type of product that most production personnel are faced with on a daily basis in the food, dairy, and beverage sector. I'm going to talk about two specific pump types today, both of which are positive displacement pumps and would be seen as slightly non-conventional in terms of the types of pumps that production personnel would be faced with on a daily basis. Those being peristaltic hose pumps and soil pumps. These are two hygienic positive displacement pump types currently making an impact in the food sector, mainly as a result of recent advances in material technology and the willingness of production engineers to consider less traditional pump types. Peristaltic hose pumps. I guess the first place that anybody would see a peristaltic pump up close is probably in a hospital on a dialysis machine. They've moved on from that into the industrial process sector, and advances now, particularly in hose technology, have driven the traction that they're gaining in food production. Up to now, peristaltic hose pumps were primarily used in the industrial manufacturing and primary water treatment sector. They have an ability to handle abrasive, very abrasive solids. They will self-prime. They will dry run indefinitely, and they will develop high pressure. All of those characteristics are seen as significant value in the industrial manufacturing and water treatment sector. Peristaltic pumps contain a tube. In the pump, the product being pumped is contained within a flexible tube or a reinforced hose. The big advantage here is that cross-contamination with exposed pump components can't occur. The pumping action is extremely gentle and low shear. Now here you'll see a typical, atypical peristaltic pump animation. What you're seeing here is the pump head. That component there is known as the rotor. That is the part that actually squeezes the tube. You'll see the tube being fitted in. It's a self-contained unit. The material is contained within that being pumped is contained within the tube and cannot actually be contaminated by any mechanical components. This is a peristalsis action whereby the occlusion of the tube and its restitution creates a suction which takes product into the pump unit, and then the following roller actually pushes it out in true positive displacement fashion. As you can see, it's an extremely gentle process, imparts little or no shear into the product, can handle solids, and it operates at ambient pressure and will generate up to the system pressure required. Manufacturers such as Burdell have now developed a pump hose which is certified food quality. It's suitable for oils and greases. Up to now, such a certified hose was not available. Traditionally, MBR hose was used. It was deemed to be food quality, but it was not actually certified. The other disadvantage previously is that MBR hose would be susceptible to degradation from oil and grease, and the vast majority of food products that we're involved in contain both oil and grease. It meets the regulatory requirements, FDA 21 CFR 177 for food contact elastomers, and also BFR XX1, which is the German standard. The hose now has 100% traceability and quality control right throughout the supply chain, manufactured according to CGMP, is delivered pre-cleaned and individually packaged. Very importantly, it can be CIP or SIP cleaned. This pump type will produce absolute vacuum at the suction port. Therefore, it will self-prime to full vacuum, which is 8 odd meters. That makes it extremely flexible in terms of where it can actually be installed in relation to the product that it's pumping. So it will literally suck a product from a container and then deliver it to the point of delivery. That makes pump installation with peristaltic hose pumps an extremely attractive option. It also makes that particular pump type a mobile pump. Currently we supply a lot of units which are mounted on trolleys and are moved within the production area. I've got a success story here. This is a story from Japan, but equally it could be as applicable here in Ireland. The company in question had to pump whole egg yolks and whites through a chilling process before dispatch to food manufacturers. These manufacturers make an extra thick omelette, which is traditionally eaten with sushi. Probably not a whole lot of it goes on here, but the omelette making process is something that certainly manufacturers here will be familiar with. The manufacturers themselves demand as contained a product as possible insofar as they wanted unbroken egg yolks. A more traditional pump type was used at the processing company, and they were receiving only a disappointing 20% of the yolks. They were making it whole through the pumping process. That created a dilemma for the manufacturer in question as they weren't meeting the brief supplied to them. They moved over to using a 40mm peristaltic pump which operated at a relatively low RPM of 20, relatively low speed of 20 RPM. That pump processes the egg yolks with a 70% unbroken rate. That rate was measured by the operators themselves. That wasn't a PR story from the pump manufacturer. That improvement on, or that increase in unbroken rate produced a staggering 350% improvement in the company's previous performance. With that particular manufacturer, that was the difference between retaining the contract and actually losing it. So it was a game changer for that particular company. The second pump type that I'm going to just briefly outline is a sine pump. Most people would not be familiar with that particular pump type. It emerged in the early 80s and was perfected in the intermediate period. The sine pump, it's a very simple design, but to try and explain how it operates over a phone is quite a difficult proposition. It uses a sinusoidal pumping. It has a symmetrical sinusoidal pumping chamber, and it produces the positive displacement of product as the head rotates. We have one operating down on our stand if you want to come and have a look. One of the big advantages with this particular pump type is its large pumping chambers eliminate product compression and damage to large solids. It also imparts very, very little temperature rise to the product itself, unlike a conventional rotary load pump or reciprocating unit. Advantages. Masosine are the world's leading sine pump manufacturer. They are a high-end German engineering company. Their SPS pump range offers a highly reliable alternative to your conventional air-operated diaphragm pumps or load pumps. And the AODs and load pumps would be two of the most widely used pumps now in the food processing sector. Sine pumps are ideally suited to high-pressure hygienic operations in sectors such as food manufacture. They're also widely used in the cosmetics and pharmaceutical industry. The sinusoidal rotor overcomes the limitations of conventional rotary load pumps, and it produces a powerful suction which has got very low shear, low pulsation, and it produces a very gentle handling operation. One of the very significant advantages over air-operated diaphragm pumps is that it operates virtually silently. If you have a 3-inch air-operated diaphragm pump working at 7 bar, you certainly know what area of the factory it's operating in. It's got a single shaft and a single rotor, which means that there are no timing gears as you would get in a rotary load pump or multiple seals. That makes cleaning, breakdown, reassembly and maintenance a very, very short affair indeed. In most instances, any cleaning is carried out in situ just by removing the front cover, which can be done by hand, and there's no special tooling required. Here we have a success story. I'm sure you'll all recognise that product on the right-hand side. The one on the left is a sine pump. Puckapai's they're headquartered in Leicester in the UK, and they were using conventional air-operated diaphragm pumps for transferring meat fillings. That particular plant produces over 60 million pies a year. The pneumatic air pump had a number of disadvantages, one being its noise and the second being its inability to handle the thick meat product. What was happening was the ball valve arrangement in the pump unit was shearing the edges off the meat and chicken chunks, and that produced an inconsistent product. The company installed a number of Sine SPS pumps on site, and several of these operated with the flooded suction, i.e. the sap below the hopper in question. But 3 of them used the suction lift capacity of the Sine pump to actually, for the want of a better description, sunk the product from the Euro bin. These pumps have proved ultra reliable with very low maintenance requirements. According to their service manager, it's the large pumping chambers within the Masosine pumps which preserve and maintain the product integrity. As I said, the main product they were pumping were pre-cooked meats or chicken, which were quite a fragile product and subject to damage by shear. The noise reduction, along with the hygiene, process efficiency and reduced energy consumption has cemented the Masosine pump type as a critical part of that particular production process. And I'll finish up with another success story involving pre-cooked grilled chicken breast in one form or other, either in whole form or in, if you go down to your local super value deli counter, you'll see it in the chopped up format, ready to go into your lunchtime wrap. A plant, this particular plant, is based in the US. A number of factors were driving the decision to look at the Maso pump, and one of those was a reduction in labour. So what they did was they installed 2 Masosine MR160 pumps, and that was replacing the vacuum air pump system and drop hopper arrangement. The pumps were set up to meter boneless product through spreader horns, which were supplied by the end user. 2 pumps and 2 horns were arranged to feed 2 16-inch wide, half-thick sheets of boneless breast meat onto the conveyor. That breast meat, it was whole, it was marinated. I believe it was a chicken tikka marinade, but it was whole chicken breast. It wasn't chopped or macerated. The brief was to produce a pumped product which didn't lose its integrity. This product was to be sold whole, or as I say, it would later be chopped up for sandwich making purposes. The Masosine MR160 medium duty pumps are capable of flow rates up to 20,000 pounds an hour, and they will pump marinated boneless breast, trim meat, thigh meat. They will also pump a bone-in product, and we've actually done that at a plant here in Ireland. The final outcome was an almost labour-free roasting line. Essentially what they had was 5 or 6 personnel shoveling product from a Eurobin onto the conveyor belt and then spreading it out on that conveyor belt by hand. The installation of this pump system produced or reduced almost completely that labour input. They just had one guy who was monitoring several lines, but there was no physical input by that operator. So 2 perfect and continuous sheets of boneless breast meat now continually feed a pro-griddle, leading to the oven. Labour has been reduced to less than 1 person. I struggled with that line because I was deciding what less than 1 person was, whether it was a half a person, but that's how the story was related to me. The other aspect was that marinade losses were fairly significant, and that was marinade losses were fairly significant. Were significantly near zero, and that was something that came as a secondary advantage to the process. Additionally, the product damage has decreased, and production rates are now only limited by their actual oven, freezer, and packaging capacity. Yields have increased as well due to higher moisture content, and that in itself had equated to greater profitability. I'm just going to show you a quick video of the product as it's being pumped. This video hasn't been speeded up, it hasn't been doctored, so just bear that in mind when you see the product actually entering onto the conveyor belt. That will conclude my presentation, but I'll be happy to take any questions if anybody is so inclined. Roll it there, Colette. So this is the rate that the pump is actually delivering at. As I say, it's not a speeded up process. So that's the spreader horn. As I said, the pump is just down below that, feeding from a drawing from a Eurobin. But as you can see, it's producing a perfectly formed sheet, which doesn't require any further input by an operator, and that goes straight through the pro-griddle. This is another product. Is another marinated product at the same plant. Thank you very much for your time.